Hello everyone, so welcome back to Inside Stacks. Today we are going to look at another concept in Azure and Azure Key Vaults. This concept will be around creating a self-signed certificate in the portal, importing a password protected PFX, personal information exchange. It's also called created with OpenSSL, and downloaded the entire certificate from the vault. You will also set the correct role-based access control permissions that you need to have in order to achieve this, because we will see down the line there's a common pitfall or issue that a lot of people encounter when trying to download the entire certificate uh, to be used in other systems. So as always, we are going to start with a clean resource group. We are going to create a resource group called rg-key vault cert.vc versus West Central Europe, Germany. I'm going to click next. No tags. We don't care about those right now. I'm going to create this resource group in order to have a complete 360-degree view on exactly how we're going to do things. Next steps are fairly easy. We're going to look for Key Vault. We are going to pick the Key Vault from Microsoft. Be sure that the provider is Microsoft because there are a lot of providers that offer Key Vaults. We're going to select the subscription, the plan of the Key Vault, and we're going to hit Create. Now we are prompted back to the portal, as always, the familiar interface that we have right here. We're going to say Key Vault for certificates. Let's see if this is still okay. This is already being used, so we're going to okay, this is also being used, so let's see like this. Okay, adding number just worked. We're going to go again with Germany West Central standard. If you have any questions of any of the configs here, just watch a previous video that I've made dedicated for understanding on how to deploy a key vault. I'm not going to select currently any sort of purge protection. We don't care. Not at least at this level. We're going to select role-based access control. I'm going to enable public access on networks, review and create. Everything looks good. Moving on, we're going to create this key vault. So up until here, none of the concepts that you're seeing should be new to you. If any of this is new or you don't understand, again, I have a video that's been recorded and posted earlier, just to be sure that we have all the same concepts in enforced and foundational concepts, right? So the resource group has been configured correctly. The key vault has been configured correctly. We have our key vault. So what would you normally do is want to create a certificate or import a certificate. But as always, because of the role-based access control, we first need to allow the proper permissions to be configured. So I'm going to go to add a role permission here for me, and I'm going to look for certificates. Most likely the best option for us in terms of key vault will be certificates officer. Again, this is the minimum requirement that you need to have in order to be able to generate or import certificates. I've selected myself as a member of this role. I'm going to review and assign. We now are going to wait for this to be propagated. To ensure that this is properly configured, we should refresh, and as you can see, the option or the error or notification that the operation is not allowed by RBAC has disappeared. So let's start with a very simple concept called a self-signed certificate, which is a certificate that you can use internally without any sort of public exposure, as this certificate would not be recognized outside of your environment. And even then, you will need to make certain configurations. So let's pick a name. We're going to say here demo cert. The type of authority that we have here is self-signed certificate, certificate issued by an integrated CA. That would mean you would need to configure a CA in your own environment. Link, for example, DigiCert is a CA. You would configure in your key vault user and password in order for the vault to be connected to your provider of CAs. In this case would be DigiCert. Then you would be able here to, as you can see here, providers options, global sign and DigiCert. You have a name, an account ID, organization. You would complete these details, and then you would have that option to use this integrated CA. You could also use a non-integrated CA. This means you would generate the CSR only. You would download the CSR from your certificates area. You would get that signed by the authority and then merge inside of the key vault again. But for our test and purposes, we are going to use a self-signed certificate right here. We're going to pick a common name, let's say democerts.com, because let's keep it in the same line. Validity period would be in months. We are okay with 12 months. Just be careful that as we go through 2025, 2026, there will be scenarios when this is way too much of a period because of all the new techniques to crack and exploit different certificates and other concepts like this. From a cybersecurity perspective, they are recommending slow to move to a more secure and period to a more secure and less lengthened period for a certificate validity, right? So we are going to pick in terms of content type is going to be a PKCS. And right now, because we don't really plan on keeping this, I'm going to just select renew at a certain days before expiry, right? So it's just going to try to renew the certificate. The most important part is right here when we are going to advanced policy configuration. Don't get scared. I know there are a lot of options here, but the one that we really care about right now is this exportable private key. This is really what we care about for our intents and purposes right now, that being able to completely download the entire certificate, not just the public side or the private side, right? Because to try to better explain this concept, what I'm trying to say here is that by default, when you have a certificate, you have a public side of the certificate that sits in the certificates area and a private side that sits in the secrets. As you can see, now we created this one. We are going to refresh to see if the process is complete. The expiration date will be next year. We are going to go here. We're going to pick the version, and now everything looks fine. We're all good, right? We're going to try to download this one. But as you can see right here, there's an issue, and Azure has a terrible way of showing you exactly what the issue is. So if you ever encounter this sort of issue, fail to dynamically fetch target URI in this particular scenario for key vaults, it means you are missing a permission. As I just iterated before, there are two parts to a certificate. The public side that you can download. If you want to do a backup, then it's going to download it and fine, all good, but it's not the entire certificate. In order for you to be able to do this, we are going to require an extra permission. This permission is related to the secrets, because the private key sits in the secrets area. Although it's not visible or not obvious, in order for you to get this role, you will need to have the secrets officer permission. You're going to select again yourself as a member. In this case, it's going to be me. We're going to review and assign. And now the role has been created. Although role is created, you don't see anything here. That's the weird part, as you would say. So if you ever encountered this issue, and you had to download the certificate and you couldn't. The reason was you were missing a permission in terms of secrets. Now, if I'm going back here and I'm clicking on download, as you can see, now I am prompted to download this certificate, and it works beautifully. Okay, so this concludes the first part of creating a self-signed certificate, creating the entire certificate, and then downloading the certificate. Now, with this being done, I would like to show you the option of where you could really just generate a new certificate. I'm going to pick a non-integrated CA for this demonstration. I'm going to mydomain.com because it's easy. Again, we're just going to be sure that everything is by default set up. I'm going to hit create. The main difference between these two is that, as you can see, the demo certificate certs, the first certificate that I did, that was a self-signed certificate. It didn't require anything else. But for this one, as you can see, it's in progress, failed, or canceled. So one of them, that's how they group it. In order for you to ensure that this is going to be a certificate that's going to be usable, you're going to go to the certificate operation. You're going to download the CSR. You're going to sign the CSR with your non-integrated CA. And then you would merge the signed request, basically that file that you signed in the CA with the CA and all that. You would click on merge sign request, upload that part, and you would get to a point where the demo certs would just be alongside with the new certificate in a completed state. And from there on, it's exactly the same thing. You just download the new certificate because your permissions already have been set up. Cool. So now that we looked from a perspective of portal, which is cool and nice for very short operations, we need to understand that usually these sort of operations are being done at a level above just ClickOps in a portal. Being a cloud engineer, being a DevOps engineer, you will need to know certain techniques in order to easily create a certificate. So with that intents and purposes, we are going to reuse the same key vault, but we are going to generate the self-signed certificate using OpenSSL. In order to do this, you need to have OpenSSL installed. You can see right here, I have it installed. And we are going to do the following command: OpenSSL request x50509. We're going to say new key. It's going to be an RSA 2048 key, SHA-256, and the days will be 365 for expiration. I'm going to say no DES. I'm going to say key out. It's my cert.key. Out is going, out is going to be my cert.crt. And the subject will be something like, I don't know, let's say CN of OpenSSLcert.com, because we are using the OpenSSL tutorial on this one, so it's going to be easier for you to know exactly what we used. Okay, so I may have here some small mistakes. Let me see. It should be days. Okay, cool. So now it works. So we generated this one. Cool. Now the next part is going to be to package this one into a PFX file in order for us to be able to upload it into our Key Vault. We're going to say OpenSSL PK CS12. We're going to say export. The in key will be my cert.key, the one that we used above, as you can see. And then we are going to say we are also giving in the my cert.crt. We're going to say out in this scenario, my cert.pfx. and the password, because pass out, pass, I don't know, strong password with an exclamation mark. Probably put a quote somewhere. Let's see. Yes, forgot the quote. Okay, fine. So now everything seems to be working. Cool. So now we generated this. We have no error. That means everything is working. We're going to go to import. We're going to say the certificate name, which, if I have not forgotten, this should be openSSLcert.com. OpenSSLcert.com. Let's just open up SSL cert, and our file should be, let me see where I am right now. pwd, going to be in downloads, Python scripts, and we are going to see here the my cert PFX, right? So that should be the we need to take. So we're going to go into downloads, Python scripts. Let's find it. Okay. Do I have it here? No. Okay. PFX. Let's see if I can find it like this. Yep, myser.pfx. This is the one. I have to click open. Strong password with an exclamation mark in order for us to be able to open this one. Okay. Probably I've done something that's not right, so we are going to redo this again. Import. Okay. I most likely made a mistake around here. Oh, okay, yeah, the password was wrong, sorry. So OpenSSL, I'm going to pick again the cert. In this scenario is Python scripts, scalar, my cert.pfx. Last time when I did this, the mistake that I made was to put an exclamation mark, which in this scenario doesn't have one. So right now I'm going to write strong password, and it should allow me now to import this one. Yes, so it wasn't really, it was just a typo from my end, right? So now you can see we have this imported here. We can do issuance policy around it. We can make sure everything looks fine. We can manage the entire operation if there's a necessity to do that. But if you click on here, you can always download it again. As you can see, it is the one that we created. You can, if you ever lose it, basically it's in a secure location. You can do whatever you need to do on this. So hopefully this tutorial was helpful. I know it's a bit short, but it's to the point where you understand common pitfalls, common issues that people may encounter when trying to use the Azure Key Vault and actually downloading the entire uh, PFX file to be reused in other scenarios, because you might have legacy applications or legacy apps running on premises or running in different scenarios where you cannot link the key vault directly to a resource like you can do in most of the scenarios in Azure. So in this scenario, this is one of the benefits of having a centralized location where you can store your key vaults, and you can really benefit from the protection from a managed system from Azure. If you like this video, leave a comment. Let me know, what do you think about this type of content? Do you feel like you're getting your answers? Do you feel like this type of content will be helpful for me to continue to do? If that's the case, hit the subscribe button, hit the like button, because that really helps me to understand better what you guys are expecting from my side, so I can, provide even better value. Thank you very much. Have a nice day. Bye bye.